Welcome to the new videos episode of our OpenStack practical series. Today we'll talk how you can build yourself the real-world OpenStack lab. We'll talk about the lab because we will use a relatively small scale. However, all the components that you will see in this lab, they are really used in the production setup, and in theory, some of these lab elements you could directly build in your lab and get the fully up and running production or cluster. So when we was analyzing the OpenStack video materials and trainings existing these days, we have figured out that the vast majority of them have the same problem, such as, first of all, they don't explain much in depth why the certain components is used, how it is working, not talking necessarily only about OpenStack itself, but also about the underlying infrastructure. From our experience, you can confidently build OpenStack or any other system, as well as operate and troubleshoot only if you understand what's going on under the hood. And this is important and piece of the training which quite often being missed. There are multiple reasons for that, because on the one hand, quite often the OpenStack training is delivered by certain vendors such as Mirantis and Red Hat. They have their own professional service, how to build OpenStack. They have their own already lined up designs. They just need the customer to follow that one, or even the professional service team themselves to build it without customer really looking too much into the details. Knowing how and why and what you have within the OpenStack design, OpenStack cloud itself, what are the components, how they're working together. It's very important in order to be able really working solid design. So second one, all of the training that we have seen somehow going into the direction usage of either pre-built host, or in vast majority of the cases, just all-in-one host setup. It's possible because OpenStack is a collection of the services. You can install them all on the same server and you could practice the basics of the OpenStack. However, it will never give you a nearly real experience, which is operation and build of the real OpenStack. There are a lot of various moving pieces and the components which are often not shown, and this is what we are to cover in today's video. And generally, this is what we are trying to achieve with our video series, to give you real practical OpenStack knowledge that you can use in your production setups. And the last but not least is quite often the companies that are chosen particular training, they are bundled to experience of the certain individual. If you are training there, taking the training from individual contributors, or biased by the vendor opinion, what they have implemented in the as a charmed version of the OpenStack. There is, even when we talk about the OpenStack networking, at least 4 ways how you could build OpenStack network. And in the training that you take from any vendor, highly likely you will be shown only 1, at max 2, without that much explanation of pros and cons and what is the different mechanics. This is again what we are willing to cover with our video series. Now, in order to start somehow coming from the theory to a practice, let's see how the component of the cloud services, which we was discussing previously in the videos, computing, networking, and storage, are mapping to the infrastructure components such as servers, switches, and the firewalls. So first of all, computing part of the cloud services, such as CPU and RAM associated with the customer's VM or customer container. This CPU and memory comes from something, right? And this something is a server. So the physical servers where we run the customer's workloads, so VMs, containers, need to have a sufficient amount of the CPU cores, as well as gigabytes of RAM memory, hundreds of gigabytes of memory, depending on the budget and depending on the amount of workload we are willing to write, as well as a high throughput network interface card, because servers which runs customer VM need to be able to process all the management traffic toward the server for the OpenStack itself, the user traffic between user VMs and towards the internet, as well as a networking traffic towards a storage node. Now, you could think, why do I need to have a traffic towards a storage node? So storage service, this is a block storage, which is the volumes of our VMs or disk images, as well as objects that, such as simply file share like AWS S3 type of experience. So what is the difference between the servers used for computing and for storage type of the cloud service? The difference is disks. For the computing nodes, so for the nodes, for the servers where we run VMs, we generally need to have a tiny disk to run on the operating system itself. It might have also, I mean, further like swap space and so on, but we don't store normally, if we talk about the production OpenStack, disk images. This is where storage services is coming from. So we're storing the VMs images on a physically separated host, and there is a networking connectivity from the servers running VM to the storage server where the disk is stored. So therefore, we need a huge amount of storage space as well as high throughput connectivity, because I said the connectivity between the VM and the storage is through the network. Obviously, it means also that this connectivity should be stable, reliable, and low latency in order to avoid problems with the PVM performance. Generally, the requirements to the RAM and CPU of the storage servers are lower compared to what we have in the computing, but all these parameters they may vary depending on the amount of the traffic and the workload, how intensive we are using block or object storage. So there might be change. We'll talk about the sizing later today. So the last bit is networking. So there are two types of the networking, obviously, where we have first about the OpenStack infrastructure itself. So switches, which are interconnecting servers used within the OpenStack cloud, as well as a firewall, which is protecting access to the user UI, what we were talking in the previous videos, and API. But this is touching the OpenStack infrastructure. From the user services perspective, we need to have, again, dedicated server, which is providing the networking services. So the network services provided on the dedicated servers for customers are virtual routers, virtual firewalls, virtual load balancers. And in order to provide this type of the service, you could think about load balancer is another VM. It doesn't have to be VM. There are different ways. Likewise, virtual routers, it can be VM, it could be just a namespace. Still, you need to allocate memory and CPU resources. As traffic forwarding is done through the server, it means so that CPU and memory, mainly CPU, are consumed by the traffic forwarding. Therefore, we need to have a sufficient amount for the user traffic to be passed. Again, high throughput network interface cards, because the network nodes, they are passing the whole traffic from the customer VMs to the internet and back, as well as a communication between various different user virtual routers or virtual networks. There are options. Again, when we talk about the networking, there are ways where we can do the distributed routing. However, in many OpenStack setups, this virtual router setup is centralized. So as we start touching the OpenStack services, it's worth to touch a little bit the OpenStack terminology in terms of the server's names. So there are 4: controller node, compute, network, and storage nodes. We'll start with the compute nodes. We'll jump back to the controller node a little bit in the end. First of all, compute node. This is technically the server where the customer VMs or containers are running. So this is a main server which is providing the services. I mean, all of them are important. I cannot say this is a VM, but this is where really customers VM being hosted when it is active. So the compute node can also run containers. There is a type of the OpenStack server which allows to run the containers. We'll touch them later in our training, but for the time being, let's focus on the VMs. So the network node, as mentioned beforehand, it runs the virtual routers as a main its functionality, which is providing the internet access to the customer's VM, as well as the connectivity between different virtual networks of one customer, so between multiple customers if such connectivity is needed. Besides that, it hosts auxiliary services such as virtual load balancer or firewalls if you have enabled them, as well as the HTTP server and network and metadata. There are also storage servers, which is or storage node, the OpenStack term. This is a server where we run the block storage. This is a service we would have a huge amount of disks to store all the images and the volumes and all other things. So these three types of the service, compute, network, and storage, they are providing the networking services themselves. However, in order for OpenStack to work, one of the terms used to describe OpenStack is cloud operating system. And there should be some node which coordinates communication between this node. This is what controller node is doing. It's running the key OpenStack services, APIs for customers to interconnect with OpenStack and get the OpenStack services UI, as well as all other non-OpenStack but critical for the work of the OpenStack components, such as database, messaging buses, which are used to like store the data about the OpenStack services and states, or communicate between various OpenStack applications. Now, these four type of the nodes will later look more in depth in the OpenStack, but when you think about how to build OpenStack, this will be like a little bit overcomplication. So we'll need to be interconnected somehow. So as said, we are putting outside of our training the OpenStack all-in-one deployment. For them, we would refer you to the official OpenStack vendor trainings from Mirantis or from Red Hat, or there are also a bunch of nice trainings on the Udemy. We will focus on the full scale OpenStack setup. You could see that it's relatively beefy. So 10 nodes, 3 controller nodes, 2 network nodes, 2 compute, and 3 storage nodes. So talking about the controllers and storage, 3 is a magic number in the high availability, especially when we talk about the databases. In order for database to work properly for high available database, it requires to achieve a quorum. And quorum is basically, you could think about as a majority. So if we have a 3 copy of data, we can take one node down, or we can corrupt data in one node. And still, if we are doing the voting, we could see that on the 2 nodes, we have the same version of data. On the third one, we have a different, right? What if we have only 2 nodes? We have on the one node data corrupt, on another it is accurate. How we could choose what is accurate, what is not, we don't know. That's why the 3 node is needed. It's therefore going further with odd numbers, so 3 or 5, and the more, I wouldn't say the better. It would create probably completely cost ineffective setup, but in certain cases it might be relative. We talk about probably some financial services or governmental data, where the data really needs to be replicated as much as possible for protection and for legislation purposes. So therefore we take as 3 controller nodes. Now, controller, as said, they're running their user UI for the OpenStack, the API for the OpenStack, all control services, which is such as authentication, authorization of the OpenStack, creating all the users, projects, and all other things, as well as core non-OpenStack services such as distributed database. In OpenStack, it's used by default MariaDB in the high available setup, relying on the Galera cluster. RabbitMQ, this is messaging bus used to OpenStack source interconnect to each other. Again, 3 replicas is deployed on each of them nodes. And we have further memcache and etcd, so 2 more like a memory database and other stuff that I needed for the OpenStack to work. So as you see, it has 2 network interfaces, management admin and management external. Management admin, this is normally not available through the internet. This is a network where the OpenStack services talking to each other between themselves. And this is an interface or network which we are as a network, the OpenStack admin, using to connect to the servers to do their job. So there is also an external management. This is a network which is normally protected by the firewall and available on the internet. So we could either have directly public IP addresses in this network, or we would do a NAT to a certain IP address within this network. This is where external customers are connecting to the OpenStack, to the UI, or to the API. Now, you see these networks, they are admin management existing on all the nodes, admin external existing on the controller nodes, and the networking nodes. Now, networking nodes mainly, as I said before, acting as virtual routers for the customers. They're providing the connectivity. Also, there are 2 because we provide in the high available mode. When we talk about the networking, we normally 2 is a number for high available. We build always 2 PE two leaf switches or two border routers. We don't generally build three. Two is good enough. And a lot of the networking protocol from the redundancy perspective, such as, for example, VRRP, virtual router redundancy protocol, is also acting that one of the router in pair is active and another is standby. You could have more than two in the VRRP pair. Just again, from the cost perspective, not really much efficient to have more than two. So, however, we'll talk about that later. We are building the OpenStack with Scala, and with Scala, we have a possibility to deploy a virtual load balancer, which is relying on two components: Keep Alive D, which is Linux implementation of the VRRP daemon for the servers, as well as HAProxy, which is open source load balancer, so TCP load balancer, I mean layer 4 load balancer, which can then send the traffic to track the availability of the controller 1, 2, and 3, and then the traffic either in the route robin or first to the first node, and if the first node in the available to the second and the third. TLDR, the management external network, in the way how it is implemented in the OpenStack, if you build it with Ansible call, would allow us to have a virtual IP address, which is running on the load balancer on the network 1 and 2, which is attracting customer traffic, and then it is redirecting to the corresponding controller, so that if any of the controllers going down, nothing is changing for the customer. From the customer perspective, the customer all the time is hitting virtual IP address running on the network in 1 and 2. So network in 1 and 2, besides having the connectivity to the management admin external network, has two more networking running on them, which is a data provider network and data tenant network. Data tenant network, this is a network used for the overlay tunnel. We will be using now deployment VXLAN. There are other options. It could be VLANs, it could be GNIF. So there are multiple options available for you. So basically, this is a network where the customer traffic is being run. So normally VXLAN these days is a de facto standard because it allows, without integrating with the networking switches, create a multiple virtual networks and using the VXLAN encapsulation to send the traffic within the corresponding virtual network between the network nodes and compute nodes, or between the compute nodes themselves. So, and data network, data provider network, this is where the external traffic is used. So you see, this network doesn't have IP address because the network nodes, neither compute nodes, have IP address themselves on this network. So the VLAN or physical interface is terminated. This is a network where the VMs are attached. If we attach public IP addresses to the networks, to the VMs, or if we're using the virtual routers, which are having public IP addresses, they are residing there. The host is such, the server don't have IP address in the provider network. Compute nodes, we have only two. You could think about, wow, the overhead is so huge, 10 nodes and only two compute nodes. If you like, you could scale it more, 3, 4, 10, whatever. This is the amount of the node that could scale further as much as you need. But two normally is a bare minimum, so that if one of the done, you could reinstantiate the VM of another one. And storage. There are 3 nodes that needs to be run, again, as said before, from the current perspective. So you could think about, wow, that's a lot in the training. I have seen that I'm downloading one VM with 8 gig and it is 8 gig RAM, 1 or 2 CPU, and it is working. Yes, it will, absolutely. And I myself, coming from the networking background, and I was passing all sorts of networking certification of Cisco, starting from the access associate level, CCNA, and then CCNP professional and the expert. So the more you climbing up, the more you understand the system, the more components you are bringing to the setup. Same story with OpenStack. If your focus is just to pass a COA exam and add to your LinkedIn page, fine, you don't need to watch this video. But if you really want to understand how OpenStack is working and be able to build your own OpenStack, well, this is video for you. And that's why you need to have non-all-in-one setup. In fact, when I was preparing to the COA exam myself, I didn't take a shortcut of, okay, downloading the all-in-one setup and just to meet the straight now. I spent roughly 3 days trying myself to build the OpenStack. I was failing and failing and failing until I get it working. And one of the purposes actually of this video series to share the experience how you can build the OpenStack, following all their productional practices, so that you can, if you are willing to prepare to exam, which is, by the way, not the bad idea, is good, but to prepare the exam on real OpenStack setup, knowing how you can build OpenStack, not only which buttons you need to press in order to create the project and the tenant and resources, or which API commands to send. So obviously 10 VMs or physical servers could be a lot. It's possible to build a smaller setup, still being a production ready. So this is what we call as hyper-converged OpenStack cluster. So hyper-converged clusters, shortly HCC, crashes down the setup. You see literally twice. Instead of 10, we have 5 nodes. We have a combined networking and compute node, as well as controller and storage, mainly because they are kind of having the similar resilience logic behind. On the OpenStack store, meaning controller store node, we run in all the OpenStack controlling services, authentication, image placement, then and all the OpenStack non-OpenStack core services such as database, MariaDB, message bus, RabbitMQ, etcd, and memcache, as mentioned before, as well as the OpenStack, not the OpenStack storage services. It's possible to run the OpenStack storage services, but they are not as the OpenStack send the documentation production ready. So we'll use something which is production ready, software-defined storage on top of Ceph, which is these days one of the most popular and de facto the standard for the OpenStack storage services. So again, for Ceph to run, it requires 3 nodes in the cluster. This is nicely matching in these 3 nodes. And the compute nodes and the networking nodes, again, from redundancy perspective, they have the same functionality. Same amount of the VLANs, as you have seen before, but slightly different mapping with the rest. This setup, again, is fully productional. Such type of setups could be built on the remote, like if you talk about the 5G far edge sites, where we need to have some compute service to provide value-added service to the customer, but we don't want to build the full-featured OpenStack. Well, we want to build full-feature OpenStack, but we don't build like 20 servers and so on. So hyper-converged cluster perfectly fits this purpose. Now, how you could build the lab, right? You could think about we using the servers, SAMs, VMs. What is the basic elements for that? Well, the reality is there is no shortcuts. The one who was preparing ever to any like CC level certification knows that in order to prepare for the exam, you need to have a full-scale lab, which is 20, 30 routers. Same story with the OpenStack. The only difference, we're talking not about preparing here for particular certification. However, it is useful to build yourself the OpenStack for the CA exam, just because you will know how to troubleshoot it. And the troubleshooting is a part of the CA exam, but also so that you can bring the OpenStack knowledge, how to build it to your network and really build it from scratch. So with this, from the experience of what we will be building during this video series, each VM would need to have 8 gig if you build full scale, or 12 gig if you run hyper-converged cluster. One of the beauty with this is what we need to allocate in the very beginning. Obviously, the VMs would not run all of this amount of the resources, so we could achieve it to a degree level of oversubscription, but it's better to plan like 12 gig if you build the hyper-convergent cluster, 12 by 5, so it's 60 gig of RAM you would need to have. If you have your own home server, it's quite cool. We'll talk about that in the moment, but so you would need to have something. Also, we allocate the 4-core per node, so meaning 4 by multiplied by 5, so 20 cores. It's something, or I mean, virtual cores, so meaning hyper-threaded to physical cores. It's perfectly matching to this needs. At the bare minimum, you need to have a 40 gig of the disk for each node. Obviously, we're not talking here about the production deployment. We're talking about the lab. For production deployment, we probably need about like 200 gigs of the storage node at least for each of the nodes. And for the storage node, in our case, at least 40 gig, just to show how the storage is working. But in the production, you will be talking about the terabytes, 2, 3, 10 terabytes of the disk capacity per each storage node. So what are the options then? Well, the first option is to go shopping and buy a used service, for example, the eBay. The price per country would vary. In US, services are costing cheaper than in the, for example, APAC region, or than in Europe. I don't know actually why, because generally the used servers are all the time the same. But when we were looking to buy the servers on the eBay, we saw that, yeah, in the US prices are lower. But you could think about that this could cost you a bit of money. Again, if you ever build this CREC, you know that could cost you quite a bit of money. So depending on the amount of the resources, if you take a look on our suggestions, it probably would cost you about like $1,000 to $2,000 US. So quite a lot, quite a commitment, but it would allow you to learn how to build OpenStack inside out and be able also to probably run afterwards your own micro cloud or hyperconverged cloud with the services. So second option is much cheaper, is to run all the VMs, all OpenStack nodes as VMs. So this is what we'll be using in our video series. Each of the nodes will be a VM. So under the hood, in essence, you need just to have one server with a set at least 64 gigs of RAM. So roughly 200 gigs of available capacity in order to create all the VMs and the connectivity. This approach is good, and a good probably to start before you could go to the option one. First of all, to buy a single used server on the eBay is much cheaper than to buy 5, even if the spec of the server is bigger. On the other hand, you would be able to focus solely on the OpenStack without the networking part. The networking part is important if you really want to go the part to the path building your OpenStacks, I mean, productional wise. So yeah, you could also use a public cloud, so such as AWS or GCP. You would have some costs associated with this deployment, definitely, but this probably would be, depending how quickly you'll be progressing, still lower than to buy a single server. We wouldn't necessarily be recommending something. It's really all depend on your commitment, on your interests. The general rule of thumb, having your server at home where you could run the OpenStack or any other services or networking lab or software development, we believe is the most appealing, but and from our experience provide the best resources and result, but it's up to you to choose. So the last point to touch is how you could improve the OpenStack. So even from what we were sharing, we have shared both in the hybrid converged setup and for the Fullscale OpenStack setup, number of servers, some ideas on the scaling, as well as some ideas of the networking connectivity. So one of the points that you might have pointed out, we're using private IP addresses for the provider network. Normally, you would have it public if you talk about the real life setup. The management traffic to the firewall in the production network will always go through the firewall. You don't want to put the servers directly on the internet because it could be attacked, hacked, and whatnot. Whereas having the firewall up front will help to protect it. On the other hand, you would not put the firewall, physical firewall, up front of the user data. I mean, you can do it, but the amount of the user data could be hundreds of gigabits per second, and it would be, in many cases, just unreasonable to have that firewall. Therefore, what you can do, if you have possibility, just to put public IP addresses directly on this data provider network. Second is, quite often you might see or have heard that in production network, we have two VLANs for iSCSI, so the network which is used for the storage connectivity between the VMs and the host, because they're kind of redundant A and B fabrics. They're working in the active standby fashion, so that if, and normally in the live deployment, they're physically separated. So you have two iSCSI switches. We don't deploy this because we are not focusing on building that. So in our case, we build a high available Ceph cluster, and we already would have the necessary level of redundancy. But again, you can look into this option as well to increase and even further the robustness of your OpenStack setup. And the third is adding more disk storage. Technically, we have set at least 40 gigs because we won't be running the super big VMs, but obviously going the production, especially if you buy a 5 physical server, you could think about that instead of 40 plus 40, you would like to run 200 plus 1 tera on something like this. So the more disks on disk space you have for your storage node, especially if you think that OpenStack not only for the purpose of learning how to do, but also to have your own cluster for your own networking projects or software development project or data projects. Think about having this data. Thank you very much for your attention today, and I will see you in the next video series. Take care and goodbye.